we're looking at section 5.4, part 2. What we're going to be looking at that's a little bit different than what we were looking at is now we're going to have rational exponents. So instead of having radicals over our x's, we've got the rational exponents. It's done in a very similar way. We still want to isolate this rational exponent part, so I need to get rid of the 1/2. I'm going to multiply both sides by 2. At this point, I want to be able to get x to the first, because that's what I want to solve for, is x. What power would I raise this to then? What is it, guys? 2/5, right? So if I raise this side to the 2/5, I also raise this side to the 2/5. And so when I solve this then, I'm going to have to multiply these, and I get 10/10. Well, that's just x to the first. Do you know the 5th root of 32? And then square it. And then that's our solution, and we should check. Square root of 4 is 2. 2 to the 5th is 32. Half of 32 is 16. That's our answer. For number 8, again, I want to isolate this part. That's basically our radical part. So we're going to subtract 28 from both sides. After I do that, I'm going to have 6x plus 10, quantity to the 7/3, is equal to 128. Now I'm going to have to raise both sides to the 3/7 power. If I have the 7/3 power and I raise it to the 3/7, we'd multiply. That becomes just 6x plus 10 to the first. What do you think the 7th root of 128 is? Going to be 2. 2 to the 3rd is going to be 8. And so now solving this, I'm going to subtract 10. That's going to give me 6x equals -2. So x is going to be -1/3. So now checking that, 6 times -1/3 is -2, plus 10 is going to be 8. Cube root of 8 is 2 to the 7th. Is going to be 128, plus 28 is going to be 156. So that works. All right. On the next one, we've got 1/2 of x to the 1/4 equals -4. If I multiply both sides by 2, I get x to the 1/4 equals -8. So this would mean that the 4th root of some number has to give me -8. What do you guys think?
No solution.
You're right. This has no solution, and that's because we have an even root that has to be equal to a negative. If you're not sure if it's no solution, I'm going to go ahead and graph this just to show you. You don't have to graph it, but you can just watch. If I graph this, this is the way 1/2 x to the 1/4 looks, right there. And then here's my line y equals -4. Can you see how those two are never going to meet? So we have no solution. There's no x that's going to make them equal. Alright, going down here now. This is a little bit more challenging, solving the inequalities, and it has to do with understanding the domain of the function. At the very beginning, I have a radical function. You should know that radical functions usually look like that. So the domain is typically x must be greater than or equal to 0. That's because if I have y equals radical x, I don't want to have any negatives under the radical. So whatever's under the radical has to be greater than or equal to 0. What kind of shift is this going to be? To the what? Right one. So now this domain would be that x values will have to be greater than or equal to 1. I have to keep that in mind throughout the problem. Solving this problem, I want to get the radical by itself, so I'm going to subtract 3. Then we're going to divide by -4. Does anyone remember with inequalities what we do when we divide by a negative? Flip it. So now it's square root of x minus 1 is less than or equal to 1. Now I'm going to square both sides. And I get x minus 1 is less than or equal to 1. And x has to be less than or equal to 2. And that's the answer that most people give. X less than or equal to 2. Not correct. Because back up here at the beginning, we already said x has to be greater than or equal to 1. So that means 1 has to be less than or equal to x, and x has to be less than or equal to 2. Those are our only solutions right there. The directions say to write the solution in interval notation. So that means that we're going to start with our lowest value of 1, go up to our highest value of 2. There's the answer in interval notation. I want you to look at what we're doing from a graphing perspective. We've got negative 4, radical x minus 1, and then plus 3. And then I've also got negative 1. So I'm going to graph these. And the question is asking, where is it that this radical function is greater than negative 1? Can you see how the radical function is greater than negative 1 only from here? Only in that little region right there, those x's? Can you see how that x is starting at 1 and then at 2, that's where they meet? See, all of algebra can be done graphically. I mean, you could figure this out on the graphing calculator. So I can see that from x equals 1 to x equals 2, that's where the radical function is greater than the linear function of y equals negative 1. Make sense? All right. How do I undo a cube root? Cube both sides. So if I cube both sides, I'm going to have 2/3 x plus 1 is less than 216. Subtract 1. 2/3 x is less than 215. Multiply by 3/2. And x must be less than 645/2. I'm supposed to write an interval notation, and so that's going to go from negative infinity to 645/2 with a parenthesis. Why didn't I put a restriction on this? Right, cube roots don't matter. Remember what those cube root functions looked like? They went into the negative region. So much for my perfect video notes. It will. You can come back and watch it. Alright, so look up here, guys. Here's our cube root function. This is asking, when is this cube root function less than 6? Can you see how it looks like it's always less than 6, right? But where are they going to meet? Way out here at about how much? What is that? It's 300 and something. I'm going to make it 350 just to make sure I'm high enough on it. So here's the cube root function. Can't even hardly see that other little part. And the question is, where is it less than 6? So it's less than 6 until it gets to that point right there. And guess what that point is? Should be 645/2. And it is 322.5, correct. Okay? All right, number 15. I'm going to add 39. Okay, we're going to divide by 2. Okay, now before I go any further, I need to look back here. Don't forget that domain restriction. Would I have a domain restriction on this problem? What's going to have to be true of x? Greater than or equal to 0, doesn't it? Because I'm not allowed to have negative numbers under that radical because it's an even root. Only when it's even roots do I need to be concerned about that. Odd roots are fine because they go on, I can take the cube root of a negative. Alright, so now I've got this, I'm going to square both sides. I'm going to multiply by 4/3. What is that? 196. Alright, but I also have to remember that x has to be greater than or equal to 0. So as an inequality, I'm going to say 0 has to be less than or equal to x, which must be less than or equal to 196 thirds. But in interval notation, 0 to 196 thirds. Oops, inclusive. Alright, on Big Ideas, you will be writing it in this form. On quizzes and tests, we have you write it in interval notation. Alright, last one. This is kind of an interesting problem. In basketball, the term hang time is the amount of time that a player is suspended in the air when making a basket. To win a slam dunk contest, players try to maximize their hang time. A player's hang time is given by the equation T equals 0.5 radical h, where T is the time in seconds and h is the height in feet of the jump. The second place finisher of a slam dunk contest had a hang time of 1 second, and the winner had a hang time of 1.2 seconds. How many feet higher did the winner jump than the second place finisher? Alright, with word problems, sometimes people tend to zone out a little bit, and they're like, oh, I don't know what to do with that. What do we do, though, guys? Just break it up into smaller pieces. What do we do, Ian? Yeah, that's all they're telling us, is that 1 is the time for that second place finisher. So I plug in T, his time was 1. So this is what I have to solve for H to find out his height. The first place finisher, his hang time, like he said, was 1.2. I have to plug that in for the time. So I have to divide by 0.5. If you have one item and you divide it in half, how many pieces do you have? 2. 1 divided by a half is 2. It is not 0.5. Alright? This is really a half. 1 divided by a half is 2. So we have 2 equals radical h, square both sides, 4 equals h. So the first guy's height is 4 feet. The second person, we divide by 0.5. What is 1.2 divided by 0.5? 2.4. Square both sides. Do you know 2.4 squared? 5.76. Alright. So we've got this guy's height, this guy's height. How many feet higher did the winner jump? Just subtract, and 1.76 feet. So, here's my question. Is this a realistic problem? I always wonder about that. 5.76 times what for inches? 12 inches? So we've got, I don't know. Do you think somebody could jump almost 70 inches up into the air? I don't know. Somebody in the other class was telling me that Michael Jordan was found to have jumped over 50 inches in one of those slam dunk contests. So, I don't know. We could research it, see if it's really possible. But anyway, for our problem, 1.76 feet would be our answer.